Hi everyone, welcome to AI ML Go. This is Kinley from Singapore. Today, we'll be exploring how linear regression can help businesses predict sales trends. If you are a business owner or a manager looking to leverage on AI machine learning, this is definitely for you. Together, we will first generate synthetic sales data in Python on Jupyter Notebook. It will be an a trend dataset with random generated sales data, after which we will build a regression model and we will plot the appropriate graph to visualize the data. And then we will predict future sales. This is a simple regression model demo. In future videos, we will do the same on linear regression on Microsoft Excel and on Power BI. I will also introduce outliers on the dataset and how we can perform data cleaning on the dataset, so do stay tuned. Forecasting helps in inventory planning, budgeting, marketing, and for all sorts of business needs. And more importantly, for key stakeholders to make the essential and correct and important business decisions. Okay, let's dive into this now. Okay, this is my Jupyter Notebook page. So this is a new page, and now the first thing that I always do, so I give this name. So let's do this linear regression model demo. Okay, so rename this. So the first cell usually I put important businesses. This is a linear regression model for prediction. Business. Okay, and shift and enter. So I'll put my name. So author says my family name, Kinley is my first name, and the date. So today is the 18th November 2024. So I'll change this to markdown. So okay, so now the first cell is usually okay, I always input all the libraries here. LIB. So the first one, import numpy snp, import pandas as pd. I also need random. Okay, import random. Okay, so I need to also import the linear regression from sklearn dot linear model import linear regression. Okay, this is the linear regression model. Okay, I also need to import the matrix. So sklearn dot matrics import mean square mean absolute error mean squared SQA mean squared error and the R2 score. Okay, so did I miss anything? No. Let's run this and see how it works. Oh, wrong spelling. So this should be matrix, METRES. Let's run this again. Ah, it's working now. So after importing the libraries, the next thing that I need to do is to create a data set. So we'll create a function to create this is a function. So df create data set. So correction, create data set. So data set, because this is the dictionary, so we have the date column. So pd dot date range. Okay, start. Let's put 2024 and with 01 January the 1st and periods equals to 120 for 120 days. Okay, so then we also have the day I plus 1 for I in range 120. Then we have the sales. So there's an upward climb of 15. So this is upward trend plus 15 plus the random generated number dot randint. So between 75 to 95. Okay, for I in range 120. Okay, so we're going to return this data set. Okay, so this is our function to create a data set. So we'll have a variable, data frame variable df, and we'll call this data set to create a data frame value. So df pandas dot data frame create data set. Okay, to make sure that this works, so we'll just have a df dot head for the top 5 records. So this is the top 5 data frame records. Okay, so we'll just run this. Nice. So we have 2024 January the 1st, day 1, sales 92, 2024 January the 2nd, day 2, at 97 predicted. So we just, these are the predicted values. Okay, so now we are going to just to make sure that everything is correct, so df dot tail. So the last 5 records, so we have ends at 120, that's correct. It's at 227, 119 at 217. The end of the date is at the 29th of April. So everything looks good. So we are going to, okay, because this is a synthetic data created by us, so we know that there's no missing values, but just for standard operating procedures, we just do at least info just to double confirm. Okay, so we have date, day, and sales. So we have date time for date. Day is an integer. Sales is also an integer for this moment. but after the computation at a later stage, our y predicted values will be a float. Okay, but for now we just stay put at this. And the next thing that we need to do is to instantiate the linear regression model object. So linear regression object. Okay. So model equals to linear regression. Okay. So we need to do a fit. Model equals to fit. Okay, we need to fit in the capital X and a lower cap Y. So X is the independent variable, which is only one for this case, that is the day. Y is the dependent variable, which is the sales. So to get the X and Y, we'll do this. X equals to np dot array df dot df dot day. Then we're going to reshape this into a vertical. So to do that is 1 1. Small y equals to np dot array df dot sales. Okay, we don't have to reach for this one because it's just only one. Okay, so model and model fit. Then we also have a variable y pred. This is y prediction equals to model dot predict and based on the x. Okay, so just to make sure that this is okay, we'll see if there's any error. Okay, fit is not defined. Oh, sorry. Model dot fit. Okay, run. Oh, correction. Syntax error. So model dot fit. Okay. So next we need to calculate all the matrix, all the errors, and the R2 score, which is it's not difficult. Okay, calculate the error matrix and matrix which inclusive of the R2 score. So MAE equals to mean absolute error the actual y and the y predict. Okay, y pred. Okay, mean square error equals to mean square error here. Same thing, y and y pred. Okay, mean square root mean square error equals to np dot square root mse. Okay, now r2 equals to r2 score same thing. Okay, y dot y pred. So we need to print these values all out. So let's do this. Print f 2 3 4. Okay, the first one is mean absolute error. This one is the MAE. Okay, so it's the MAE. Let's do this as a three decimal place. Okay. Now this is the mean square error. MSE. This is the root mean square error. This is the R2 score. So the R2 score R2 dot 3 F. Okay. So let's run this and hope that there's no error. We'll see. Good. So as you can see now, the R2 score is similar to the accuracy. It's 97.3%. That's very high. We have mean absolute error at 5.1, mean square error at 35, root mean square error at 6. So these are the values for this data set we have generated. Okay, we'll go next. I'll come back to this, and we'll be coming back to this again in a while. So now we need to, after this, we need to compute the if you have a kids, if you have kids, son or daughters in Singapore secondary school, they might have already know this y equals to mx plus c formula. So it's actually the trend line formula. So this mx plus c, we need to find, we have the x value, we just need to now find the m and c value to determine the y. Okay, so m equals to model dot coefficient underscore index 0. Okay, so c equals to model dot intercept underscore. Okay, so this is the m and c extraction value for the y equals to mx plus c. Okay, just to run this and see. Okay, good. Now we're going to plot the scattered graph. So plt dot figure figure size for me is for mine is 16:8, but for you can adjust and try it and see how it fits on yours. It may be a different value. So we need to plot the scattered. So the x is df dot day, the y is df dot sales, color, let's do it blue. Okay, and label equals to sales. Okay, nice. Then we have plot dot we have to label for x label, so we'll do this as day. Plt dot y label as sales. Okay. So plot plt.title sales over days. Okay. Plt dot put in a legend, legend. We'll put this in a legend. Put in the legend, and we will put in the grid. So this is true, and we will show the plot. Okay, let's hope this works. Plt is not did I run this? Oh, we don't have the matplotlib. Import matplotlib .pyplot as plt. So we run this again. Okay, so this should work now. Figure plot figure. How come this is not working? Let's try again. Plt is plt. Oh, fixed size equal form error. Okay, so this is working now. So this is a scattered plot of our synthetic data. So from this here 0 from 1 to 120. So it climbs at an interval of 15. Then every interval of 15, it will generate between 75 and 95 value range. So this is how the plot looks like. So now we're going to include a trend line. So to include a trend line, we just need to include one more line here. So plot dot plot. Okay. Same thing. Day dot df dot day. So model dot predict x. Let's do this color equal red. Okay, then with label equals to f. Okay, y equals to regression. Sorry, regression y equal. So we have the m here, mx plus we have also the c here. So I just want a dot 3 decimal place. Dot 3 decimal place, and we'll plot this again. So now we can see the trend line. Okay, so this trend line, if you this point here and this one, this point here and this one, you see this point and this point, this point and this point. Now we go back to our formula to create a dataset. So it's between 75, so it runs between 75 and 95 each time of I. So when I equals to 1, so it's between 75 and 95. And when I plus 15, which is the second day, So I is now 15. So 15 plus 75, 15 and plus 75 and 95 range. So it will always, okay, 75 and 95 is 20, right? So it means to say that from here to here is about 10. From here is about 10. So you can see that there's a constant deviation from the point to this trend line. So it can go somewhere around 10. 10 maximum should be 10. Okay. So the wider this value, the less accurate it will be. Okay. The more error you will have. The smaller this value, that means the dots, when the dots are closer to the trend line, generally, the higher the accuracy it will be. Okay, we'll come back to this later. So now the next thing we do, once we have plotted this, we will find the next 30 days. That means we'll predict what's the next 30 days based on this trend line. Okay, so the thing that we do now is easy. So this is for the prediction. Okay, future days. Future days equals to I for I in range just 30 days. So we start with 120 and we end in 151. Okay, because we start at 120, so we need to add extra 1 here. Okay, so future sales equals model dot predict NP array. So future days need to reshape -1 1. Okay, then we close this. We actually don't need to do the future dates, but for formality sake, we just put it in. Okay, future dates, so that we can map it on which day is the date for if there's a need arise. Date range df dot date dot max. Okay, period equals to 30. Okay, so this is it. Let's see if there's an error. Future line 4. Oh, there's no equal. Okay, should be corrected. Okay, good. So now we're going to do the plot again. So we copy this, we place it here. We'll just need to add and make amendments to this. So we're just going to add this plt dot plot again. So instead of days with future days, then future sales, color, let's do green, line style equals to dash, and label equals to prediction. Okay, so now the title, sales over days with a trend line and predictions. Okay, so this is correct. Let's run this. Where did I go wrong? or here. So run this. Okay, now we have our existing graph earlier, the same here, and now we have extended the trend line. That's the prediction. Okay, so from 120 to 150. So now we're going to display all these values, 120 to 150, at the predicted sales. What are the values here, here, and so on. Okay, so let's do this. This is easy, and this is the last part. Okay, so predicted values. Predicted values for the next 30 days. So for day, sales in zip, okay, future days, future sales. Okay, we're going to print F predicted sales in future day. So future day is, then there's a dollar sign, so sales. So there's some 3 decimal place. Okay, we're going to run this. Bingo. So let's do a check first. This is day 120 to day 150. So this is not inside the actual plotted sales data that we have. This is predicted using the formula y goes to mx plus c. We predict what's the value on day 120, day 121, and so on until 150. Okay, since we have a predicted value of 120 day, that is 219, we also have an actual value on top, remember? So let's see. So 227 at the 100 is our actual value, 227, and we predicted 219 here. So that's 227, that's less than 10 difference, not too bad. So this is the values predicted until it reaches 150. So the smaller it is to the trend line, the better the accuracy. The larger it is, it will be less accurate. Okay, so this is the linear regression. Okay, now we have done this, the prediction. What we're going to do now is to play around and to change this difference. This is 20. Now we make it, the difference is 10. So this is 75 and 95. Let's make it as 85. Difference is 75 and 85. Then we run this. At this current value, 5, 34, 6, and 97. 5, 34, 6, and 97. Let's do this. We make this smaller. Okay, 536 at 535, 6, and 97. Okay, we run this. Okay, you will realize that first of all, this has become smaller. The different distance to the trend line, it becomes smaller. And when this happens, if you realize now it is 3, 9, it is 36 right just now, so it greatly reduces the mean square error, 9 and 3, and now the R2 score is 99%, which is fabulous. So let's check on the, this is on the predicted value. So 120, the predicted value is 214. Let's check the actual value. The actual value is 213. So it's only one value difference. So 214.316, and the actual okay, for day 120 we predicted is 214. For the actual value is 213. So it's very accurate. So the rule is you need to keep this small, okay, so that your prediction and your plot will be more accurate. Okay, that's it folks for today. Thanks for showing up. I hope this can add value to you and in your business needs. In the upcoming videos, we will do the same. Linear regression on Microsoft Excel and Power BI. We will also plot the scatter graph and the trend line, and also to predict future sales. So stay tuned and hope to see you again. Don't forget to subscribe and share this to someone who may need this. Bye for now.